Ladies and gentlemen, good morning. Happy Monday. Glad to see you all. Hope you had an amazing weekend. Hopefully you all did something fun. You were able to spend some time with your family, read a book, did something educational, anything like that. I am glad that you are here. Forgive me for not being here. I've had some family things going on. I've had to spend a lot of time at home with my kids, but I am still very much attentive to what it is you all are doing in the classroom. So I bet a bunch of y'all didn't think I was gonna come in here on a Saturday, but here I am. If you look over at the shelf, I have graded a lot of things on the shelf, and a lot of y'all have not gotten work done. A lot of y'all still ain't done the section assessments for chapter 13, section 1 and 2, section 3 and 4. A lot of y'all have not done that. If you're in my first core, I am going to upload the page for you to do your unpacking of the standard and objectives and the Quizlet study set. I did not load that for my first core simply because my first core has been behind. We've had so many things happen in first core. Y'all just got done taking your unit test. So I am gonna make sure that I upload that assignment as well. So if you have not done your unpacking and your Quizlet study set, I'm still waiting on that. You need to do your section assessments that are on paper. Again, I've graded what's on the shelf. A lot of y'all did not do that. These ed puzzles, get them done. It ain't but 2 of them. And honestly, I have no remorse or sympathy for this whole my ed puzzle don't work thing. You guys find all kinds of ways to make stuff work on your laptops. You guys find all kinds of resources to make sure that you can look up shoes and look up sports and look up games and look up lashes and look up edges and look up hair. You can look up different ways to make sure that your computer is going to allow you to do those ed puzzles. That web quest, I will make sure that I put a submission tab in for that web quest. I realized that I didn't do that, so I will make sure that I go back and I do that as well. Other than that, guys, please make sure you're getting your grades in. Get this stuff done. We ain't got, I think, but a couple more weeks left, and this quarter gonna be ready to close out too. And before you know it, we're gonna be in fourth quarter, which is pretty much test preparation, okay? So we are getting ready to start with the periodic table today. We have finished matter. We have finished physical and chemical change. You should have been studying your vocabulary with that. You should have gone back and studied your notes with that. Chapter 13 talks about physical, chemical change, and matter. The worksheets that we did while I was here talks about those things. So you should understand the properties of matter. You should understand change. You should understand solid, liquid, gases. You should understand what those particles look like already. You should understand that a solid is going to have particles that are extremely compact and tightly close together. You should understand that liquids still have no exact shape or an exact volume. They take the shape of whatever container that they're in. Their molecules are loose but still closer together than they are gas. You should understand that gas, air has mass. Air is matter. Okay, those atoms, those molecules, that's when you feel wind blowing, and wind actually brushes up against you. You are feeling matter hit your body. Okay, we talked about the difference between mass, weight, and volume, especially if we were changed to gravitational force. If I put a truck on the moon, the only thing that's going to change is the weight. The mass and the volume didn't change. Remember, I didn't say I took any pieces of that truck apart. I didn't say I took the wheels off. I didn't say I took the engine out. Okay, make sure you go back and you study those things. Just because I'm not here, my expectations of you are still the same. I'm gonna put away these chess boards because I feel like a lot of y'all would do things like play chess all class long and you won't get work done. I'm expecting things to be done and turned in when I get back to this building on Tuesday. Okay, so I'm happy to see you, but let's go ahead and get started with these periodic table notes. You will have 2 worksheets that will be up on my desk. One worksheet is going to be the notes for the periodic table. The other worksheet is going to be one on physical, chemical change, states of matter that you are going to be completing on your own, that I do expect to be done when I get back, okay? But let's go through this. Pause the video as much as you need to so that you can go back and you can think about things. I am available through email. Some of you all are emailing me, and I am trying my best to make sure that I email you back immediately. If I'm not seeing your email, please forgive me. I did tell you I'm at home doing things with kids, but let's roll through this. Again, if you do need me for anything, something that doesn't make sense, by all means, shoot me an email about it and we'll get through it, okay? The periodic table. We've seen the periodic table before. I have one that looks just like this. It's in the back of my room, and some of you have seen it, okay? There are different things about the periodic table that you should know. There are elements that are matter and is made up of one atom, okay? So these elements are single atoms of each of these things. So when you look at a periodic table, this first one right here, this is hydrogen, okay? This is one atom of hydrogen. Just one, okay? Later on, we'll start talking about how we put more than one of these together. We start making compounds, we start making mixtures and things like that, all right? But an atom is the basic unit of matter. So atoms, as you know, are extremely small, okay? They're beyond microscopic. It takes special types of microscopes to be able to even see what an atom looks like, all right? A periodic table was discovered by Dmitri Mendeleev, and it shows every element that exists in the universe has 18 columns and 7 periods, organized based by atomic number, okay? When you look at a periodic table, this number right at the very top of each of one of these element boxes, that is going to be the atomic number, all right? It has 18 columns. Remember, columns go up and down, all right? So it has 18 columns, 17 rows or periods, 7 rows or 7 periods, all right? Whichever one you want to call them, I'm fine with that. 18 columns, 7 periods. Please make sure that you keep that in mind, all right? Now, this is an element box, all right? Every element has a face card or an element box. It's going to give you information about that specific element, all right? Protons are positive charges, electrons are negative charges, and neutrons are neutral charges. You need to make sure that you remember that. Protons, positive, electrons, negative, neutrons, neutral. This one is easy to remember. This one is easy to remember. If you can remember protons, P for positive, neutrons, neut for neutral. If you can remember those, then you can remember that electrons are negative, okay? Now, out of these three, I think protons are the largest, electrons are the smallest, and neutrons are in the middle as far as size is concerned, okay? Each element belongs to a family. Families are structured based on similarities. Each column represents a family. You find the amount of neutrons by doing this mathematical equation, okay? Atomic mass minus the atomic number equals the number of neutrons. If you look at the element box, this is the atomic mass. This is the atomic number. So just based off of this alone, if you round this number up, this is the atomic mass minus the atomic number, gives you the number of neutrons. So let's do that real quick so you can see it. So if I round this up, 7 minus 3 equals what? 4. So your neutrons here are equal to 4 for lithium, okay? And we're gonna do that quite a bit. Remember, I told you, when it comes time to start looking at the periodic table and some of the things that we do with chemistry, a lot of this stuff is going to involve a lot of math that we're going to have to look at, okay? Now, for the most part, we'll probably always round these numbers up. We may leave them the way they are, but that's if we are going to get very specific into certain things, okay? But again, that's going to start talking about law of conservation of matter, which makes sure that we don't lose any substances at all. Remember, matter cannot be created or destroyed. It's always been here. It's going to continue to remain here. It just transfers states, or it transfers from one thing to another, but you can't destroy it. Lithium is going to always be lithium. You can't get rid of it, all right? So here you see your symbol, you see your name, you see your atomic mass, okay? The symbol is gonna always usually have something to do with the first couple letters within the name. Sometimes it doesn't, and sometimes the symbol is just completely some other random letters that has nothing to do with the name, but that's how you read a element box or the face card, however you wanna say it. It's totally up to you, okay? So here, again, iron, the element symbol is Fe, okay? But it's spelled completely different. Remember, you got your atomic number, and then you've got your atomic mass. And in order to get the number of neutrons, you have to do what? You have to do some math. You have to subtract. The atomic mass minus the atomic number gives you the number of neutrons, okay? Atomic mass minus the atomic number gives you the number of neutrons. Same thing with potassium. Same thing with this one, same thing with this one. Take some time, pause the video, try to do these last two on your own so that you can understand how to do it, because I promise you, I can come up with a quiz and just give you a bunch of these same face cards or these element boxes, and the only thing I will ask you to do is find me the number of neutrons. Okay, so make sure that you take the time to do that. And notice you don't see any decimals here. They have rounded these numbers up. This atomic mass is 55.845. Here, they just wrote it as 56. The atomic mass here is 39.09. Here, they just wrote the atomic mass as 39. So what would the atomic mass be here? Would this be 180.9? Would it be 180 or would it be 181? Same thing here. This atomic mass is 79.9. So are we going to write it as 80? Are we going to write it as 8? Are we going to write it as 79? Okay, keep that in mind. We're most likely going to round these up. Now, again, here is a periodic table. I know it's a lot to look at. Okay, your metals on the left side of the periodic table, they are good conductors of heat and electricity. This is why you do not take a fork and you stick it in a socket, because you will shock yourself. Metals are great conductors of electricity. This is also why you do not take metal and heat it up and then touch it. You ever seen metal start turning glowing red and glowing orange? That's because they hold heat very, very, very well. This is why on your stove, especially a lot of the older stoves, you see those iron rings that look like this, that start in the middle, and then they look like that. When you see that on your stove, that's metal. Why? Because metal holds really good heat. Okay, it's a great conductor of heat and electricity. They are malleable. Malleable means that you can change its shape. It can be molded. It can be reshaped. If you think about olden times where people used to use swords for weapons, that's how they made swords. They would heat them up. They would let them get glowing red, and then they would hit them with a mallet. If you can remember mallet and malleable, a mallet is like a hammer. You can literally take a hammer and shape the metal the way that you want it to be shaped. Not all metals are like that, but a lot of them are. They are ductile. What does ductile mean? Its ability to be stretched and hammered, okay? Ductile, meaning its ability to be stretched and hammered. A metalloid, went too far, but it'll be okay, I'll leave it there. A metalloid is on the staircase, okay? If you start at family 13, okay, and you walk down the staircase, this is the staircase, okay? These are your metalloids. Let me make sure I'm doing this right. These are your metalloids on the underside of the staircase, okay? And they share the properties of both metals and non-metals, all right? So they're going to have some metal properties and some non-metal properties, okay? And now you've got your non-metals, which are on the top side of the staircase. They're on the right side. They're majority gases. They're poor conductors of heat and electricity. Most of the time you are not going to get shocked because you put electricity in some type of gas. It's usually not how that works, all right? Valence electrons versus reactivity. Now is when you're going to have to start paying attention to that number that's at the top of those columns, all right? So when we go back to this periodic table, you see these numbers at the top of these columns? That's the number of valence electrons that that particular column has, all right? Now, here's where we got to be different, okay? In the middle, these have no valence electrons, all right? This has one valence electron, two valence electrons, then you skip all of this in the middle and you go 3, 4, 5, 6, 7, 8. So, for example, 18, element 18 stands for argon. If I were to ask you how many valence electrons argon has, you should tell me 8, not 18. If I were to ask you how many valence electrons helium has, you should tell me 8, not 18. If I ask you to tell me how many valence electrons nitrogen has, you should tell me 5, not 15. Okay? So it goes 1, 2, you skip all of these in the middle, 3, 4, 5, 6, 7, 8. Now, your valence electrons are the electrons that are furthest away from the nucleus. So this is your nucleus, okay? You've got your protons, neutrons here, you got your electrons out here, all right? The ones on the outermost circle are your valence electrons. Atoms can have different number of valence electrons, and reactivity is how likely an atom is to react with other atoms, all right? Some elements are very reactive, some elements almost never react. Okay, let me go back one. Let me double check something. Yeah, okay, let me go back. I wanted to make sure because I didn't know if we were going to cover that or not. Let me go back. All right. So with the reactivity of these elements, okay, the magic number is 8. Okay, so let's say you got a group of your homies, you got a group of your friends, right? And you all are at a group and y'all like to sit together and it's 8 of y'all, okay? 8 is the magic number. Everybody wants to get to 8. Everybody wants to be 8, okay? Everybody wants to be the number 8. So in your group, you already have 8 homies, 8 friends, 8 of your girls, 8 of your boys, 8 of your teammates, whoever. It's up to you, okay? But it's already 8 of y'all in a group. You don't need anybody else in your group. So you're going to be less likely to react to another element or another person or another group because you already have the number that you need. 8 is enough, okay? If I'm in a situation where I need to defend myself against somebody else, against a bunch of people, if I got 8 of my homies and somebody trying to hurt me, I got 8 people with me. I'm good. I don't need to react to nothing else. I'm straight. I got my team. I got my squad. I got my lunch table. I got my lunch buddies. I'm good, okay? But let's say it's only 2 of me, okay? Let's say it's only 1 or 2 of me. If it's only 1 or 2 in my group, then I'm going to be much more reactive because now I don't have enough people on my side. I don't have enough. So let's go back and look at the periodic table. Let's see if we can put this in perspective. So here, if I'm in a perfect group of 8 already, I don't need to react. Okay? If I got 7 of my homies, I don't need to react. So I'm not going to be as reactive here either. If I got 6 of my homies, I'm still good. I'm sitting at the table with my 6 homies. I don't necessarily need to react to anything. I'm good. But let's say it's only 2 of me. Okay? If I'm down here and I'm sitting at the lunch table and I only got 2 homies right here and I need more, I'm probably going to be more reactive to gaining more valence electrons to finally be a part of that 8. So in some cases, depending on which element you're looking at, based off of the number of valence electrons, based off the column that they are in, based off of their group, their family, some of them are going to be much more reactive than others, okay? If I already got my magic number of 8, I don't need to be reactive, all right? But if I'm sitting somewhere down on the lower end, somewhere, let's say between 2, 3, and 4, I'm probably going to be very, very active. And the thing about this group 1 here, a lot of times you're going to say, oh, that should be very reactive. But in a lot of cases, it might not need to be as reactive as some of the other ones need to be. Because it's easy to pick up 1 person versus picking up 3 people. It's like playing a basketball game. If I know you only have 5 on the court at a time, but let's just say for whatever reason for this particular game, you need 8 people to play basketball. Yes, I know you need 5, but what I'm saying is, let's say you need 8. It's easier to find 1 more person than it is to find 3 people. You see what I'm saying? So a lot of times, even on this end, you don't have to be as reactive because people are going to always want to bond with you in the first place. All right? We'll talk more about it when I get back. I hope I'm explaining it right. And then if not, then I'll explain it whenever I get back. Anyway, group 1, okay? Group 1, these are your alkali metals, okay? Hydrogen is not in that family, all right? Most reactive metals conducts electricity and has 1 valence electrons, okay? That's what I was trying to get at with that 1. That's the one that's not as reactive because it's not in that family. That's what I was trying to explain. We'll talk more about it when I get back, all right? Group 2. Your alkali earth metals, they have 2 valence electrons and they conduct electricity. And groups 3 through 12, these are the ones that are transition metals. Remember, we do not count these in our valence electron counts. They all have 2 valence electrons, okay? Everything in here has only 2 valence electrons. They do conduct electricity and heat. Group 13, 3 valence electrons, not a conductor. Group 14, 4 valence electrons, not a conductor. Group 15, 5 valence electrons, and they conduct electricity. Group 16 have 6 valence electrons. Group 17 have 7 valence electrons, and they are the most reactive nonmetals. Group 18 are your noble gases, and all gases and non-reactive, 2 to 8 valence electrons. Now, we don't really talk about too much of those. Lanthanides and actinides, actinides, I said that all wrong. Lanthanides and actinides, some are radioactive and they conduct electricity. All right. Hopefully that explained that for you quite a bit. If you need to go back, watch it a couple times. By all means, like I said, email it to me. Hopefully I explained it right. I will make sure that I go back over it this weekend as I am thinking about it to see if there's any comments or notes that I need to add for you. But more than anything, ladies and gentlemen, please make sure that you are getting your work done. Please make sure that you are taking the time to finish those notes, finish the work, get assignments and stuff turned in. Like I said, you never know when I'm going to be ready to start checking on this stuff and start putting these grades in. Those ed puzzles, get them done. That work that needs to be turned in online, make sure that you get it done. And I will make sure that I load a submission tab for it in Canvas so that you can get that web question stuff turned in. Make this stuff work, ladies and gentlemen. Happy Monday, and I will see you Tuesday.